So let's start, we'll define a parallel lines, a set of parallel lines, I should say. Parallel lines are two lines that will never intersect. So two lines, they always say two lines in the same plane. So sort of on the same graph, two lines that will never intersect. We can identify parallel lines because parallel lines have the same slope. So sometimes if you look at a graph, the lines might look parallel, and sure, maybe they don't intersect on the graph where you can see, but maybe they might intersect later on off the graph where you can't see. The only way that we can know for sure whether a set of lines are parallel is by checking their slope. Parallel lines will have the same slope. So let's look at an example here. This is example 1. Okay. All right, so I'm going to draw 3 lines here. And we'll label the points. So first we have -3, -4 is one point on this line. And 2, -5. All right, we do not have a ruler. Yikes. Okay, pretend that's straight. That's our first line. And then we're given another line up here with a point at -3, 0, a point at 1, -1. And then we are given a third line up here with a point at -4, 3, and a point at 1, 2. Okay, so I'm going to stop there for a second and let you look at these and copy them down. Now, in this graph, none of these lines intersect, right? It does not mean, though, that they're parallel lines. The only way, like I said before, the only way that we can determine and prove that they're parallel is by finding their slopes. And if any of these lines have parallel slopes, or exact same slopes, it means that the lines are parallel. So let's call the purple line A. We'll call the pink line B, and the green line will be C. So let's find the slopes of each of these lines so that we can determine if any of them are indeed parallel. All right, so let's find the slope of line A. To find the slope, we'll use slope formula, which is y2 minus y1 over x2 minus x1. So I'm going to start here, y2 minus y1. So 2 minus 3 over x2 minus x1. So 1 plus 4. When I simplify, I get that the slope of line A is -1/5. Okay, let's do the same thing for line B. Determine its slope using slope formula, y2 minus y1, so -1 minus 0, over x2 minus x1, so 1 plus 3. This gives us a -1/4. So far, we can see that line A and line B are not parallel. They have different slopes. So these are not parallel lines. My guess is that probably line C will be parallel to one of them, since that's what the lesson's about. If we use slope formula, y2, -5 minus y1 plus 4 over x2, 2 minus x1 plus 3. If we simplify, we get that the slope of line C is -1/5. So you can see that lines A and C have the same slope. So they are parallel. So we would write this. I'm just going to move this up a tiny bit. Line A, we can use this symbol, 2 long lines is parallel to line C, or you can write is parallel to, but this is sort of the geometric symbol. That means parallel. Line A is parallel to line C because they have the same slope. All right, any questions about that so far? All right.
I have. I'm sorry.
Oh yes, April.
Yeah. So if we were gonna do rise over run instead of slope formula, will we always start at the top, like the highest point on the?
Yes, I'd say that's probably best practice. And then because that'll make sure that if you are, if you have a negative slope, that you do a negative like down, and that's a negative numerator, right? It's like a fall instead of a rise.
But slope formula is obviously easier. So.
Slope formula will, I think slope formula causes fewer mistakes just in signs. But yes, you could do rise over run as well.
Okay, thank you.
Yeah. All right, let's look at example 2. Okay, example 2 asks us to write an equation of a line that passes through -5, -4. So it passes through that point and is parallel to y equals 2x plus 3. So our job is to write a new equation of a line that passes through this point, but is parallel to this line. So we know how to write equations of lines when we have a point and when we have a slope. And we know the slope of our new line because they told us that our new line will be parallel to this line. And if this line is y equals 2x plus 3, the slope of this line is 2. So the slope of our new line will also be 2. So what we can do is use point slope form, plug in this point, plug in the slope, and then get it to slope intercept to make a new equation. So let's go ahead and do that. Remembering that point slope is y minus y1 is equal to m times the quantity x minus x1. And we're going to use this point as our x1, y1. So we get that x plus 4 is equal to m, and we know that our slope is going to be 2 because this line is parallel to the line we were given. So slope is 2 times the quantity x minus 5. We're going to want to get this into slope intercept form. Okay, when we're not told what form to put it in, we should always put it in slope intercept. So we're going to keep going and get this into slope intercept form. So I'm going to distribute this 2 to both terms. I'll bring down y plus 4 just so I don't forget it. 2 times x is 2x. 2 times negative 5 is negative 10. And then I will subtract 4 from both sides so that I get y by itself. So the equation of the line that passes through the point 5, negative 4, and has a slope of 2, when we simplify, is y equals 2x minus 14. All right, April, question.
I'm sorry. Could you explain to me how, like, I guess 5, negative 4, could you just explain how it relates to y equals 2x plus 3?
Yeah, so they're giving us this point. This is a point on a different line, but it's a point on a line that's parallel to this line. So we need to figure out the equation of the line that would pass through this point that they gave us, and the line that passes through 5, negative 4 is parallel to this given line. We don't know the equation of the line that passes through this point, which is why we then have to use point slope to figure out the equation of that line.
And we can figure out point slope because 2 is the slope.
The slope, right? Because if the line is parallel to this line, if our new line that we're going to figure out, if it's parallel, we know it has to have the same slope. Does that make sense? Okay. I'm going to turn my page, actually. I'm running out of room here. Now, let's switch gears just a little bit. If parallel lines have the same slope, we need to talk about perpendicular lines. So let's first define what a perpendicular line is. Perpendicular lines are 2 lines that intersect at a 90-degree angle. two lines that intersect at a 90-degree angle. So like all these little squares on my graph paper are perpendicular lines because they intersect at 90-degree angles. Now, parallel lines had the exact same slope. So two lines that are parallel will have the exact same slopes. Perpendicular lines, so let's say the slopes of perpendicular lines will be opposite or negative reciprocals of one another. The slopes of perpendicular lines will be opposite or negative reciprocals of one another. So opposite or negative means they have the opposite sign. So if one's negative, the other will be positive, or if one's positive, the other will be negative. And then the slopes, the numbers in the slopes will be reciprocals of one another. So for example, if the slope of line 1 is 2, then the perpendicular line will have a slope that's an opposite. So this was positive. So the slope of a perpendicular line would be negative. And it will also be the reciprocal of the other slope. So this slope is 2 or 2 over 1. So a perpendicular line would have the reciprocal value, negative or 1/2. So opposite, reciprocal.
Miss Allergia,
Yes.
when we write that, do
Yep.
we have to do like do we have to do the sign where it's got like the intersecting lines and the 90-degree angle?
Like this or like this?
Yeah. Like at the bottom, yeah.
No. So I'll show you when we get to the answer. I'll show you how you write the little sign, but that's not it.
Okay.
I was just trying to sort of represent that like these two are perpendicular.
Okay.
I'm going to write it here. Perpendicular slopes.
So it has to be the opposite. So it has to be the reciprocal, and it has to be opposite the sign.
Exactly.
Okay, so that would make it the opposite reciprocal.
Right.
Okay.
Exactly. And you have to say that it's not just the opposite and it's not just the reciprocal. It's the opposite reciprocal. If it's just one or the other, then it's not going to be perpendicular. It has to be both opposite and reciprocal. All right, so let's look at an example. This is example 3. Example 3 says, determine which lines are parallel and or perpendicular. Determine which lines are parallel and or perpendicular. So maybe they're parallel, maybe they're perpendicular, maybe they're neither. Now in this example, they give us equations of lines, so we don't have to solve from points. In this case, they give us line A. And the equation of line A is y equals 4x plus 2. And they give us line B. And the equation of line B is x plus 4y equals 3. And they give us line C, which is negative 8y minus 2x equals 16. Now, in order to determine if these three lines are parallel or perpendicular to one another, we need to get them into a form where we can easily see the slope. Line A is in point slope, slope intercept, where we can see the slope. So the slope of line A is 4. So let's get line B into slope intercept so that we can see its slope. We'll subtract x from both sides. So then we get 4y equals negative x plus 3. And divide by 4. And divide every term by 4. So we get that in slope intercept form. The equation of line B is negative 1/4 x plus 3/4. I'm writing this as negative 1/4 x because it makes it very clear what my slope is. So the slope of line B is negative 1/4. And let's go ahead and solve C, put it into slope intercept form as well, and then we'll compare all three slopes. So for C, first I'm going to add 2x to both sides. So I get negative 8y equals 2x plus 16. And then I will divide both sides by negative 8. Remember, I divide every term on the right. So then I get that y equals negative 2/8, which is negative 1/4, x minus 2. So now I can see the slope of every line. All right, what do we notice? I think first the most obvious is that lines B and C have the exact same slope. This means that they are parallel lines. So we can write that lines B and C are parallel. Or we could write this like this: line B is parallel to line C. And then we can see that lines B and C have an opposite reciprocal slope to line A. They're the opposite sign and the reciprocal. So these are perpendicular. Line B is perpendicular to line A, and line C is perpendicular to line A. So we could write this. Line B, this little sign means perpendicular. It's kind of like an upside down capital T. Line B is perpendicular to line A. And line C is also perpendicular to line A. Because their slopes are negative reciprocals. All right, what questions do you guys have?
Mr. Lergio?
Yeah.
So are reciprocals, like, aren't reciprocals usually the opposite? Or are reciprocals the opposite, like, is like the reciprocal of a positive number usually negative? Or
The opposite.
You have to say opposite too.
Correct. So the opposite means the opposite sign. So the opposite of 4 is -4.
Okay.
But the reciprocal of 4 is 1/4. So the
Oh,
reciprocal is the flip. The opposite is the opposite sign.
Okay, thank you.
Make sense?
Yeah.
Good.
Okay. So far all we've done was like take a whole number and then make it a fraction. Say it was a fraction, like a negative fraction, and we had to make its reciprocal.
Yep.
So like say we had like -1/3.
Uh-huh.
Would that be like just 3?
Yes. The
It's not a
perpendicular line. Yep, exactly. It would be a
Like-
whole number 3.
Yeah.
And
Okay.
it would
So
be the
if
opposite
it's
sign.
a fraction with 1 as its numerator will always be a whole number as
Right.
a reciprocal.
It's a reciprocal. Exactly. Good. All right, let's do one practice writing an equation when we're given a point and a perpendicular line. So this is example 4. And it says, write an equation of a line that passes through -3, 1. So we're going to write an equation of a line that goes through this point. And this new line is perpendicular. I'm just going to abbreviate perpendicular to y equals 1/2 x plus 3. All right, so we need to write a new equation of a line that passes through this point. So we have a point. We can also figure out the slope of our new line because we know it's perpendicular to the given line here. It's perpendicular to y equals 1/2 x plus 3. If it's perpendicular, our new line needs to have a slope that's the opposite reciprocal of this line. So this line's slope was a positive 1/2. What would my opposite reciprocal be of the new line that I'm going to write?
-2.
Very good. Negative, opposite, reciprocal, 2. 2/1. Very good. So now I have a slope and I have a point. So I can write my new equation of a line that goes through -3, 1. So I'll use point slope, y minus y1 equals m times the quantity x minus x1. And then I plug in my given values. So I get y minus 1 is equal to my slope of -2 times the quantity x plus 3. Then I'll distribute -2x minus 6 and bring over this 1. So -2x minus 5. Oops, sorry. So the equation of my new line is y equals -2x minus 5. And then I can double check that my slopes are indeed negative reciprocals. They are 1/2 and -2. So I've written an equation that definitely is perpendicular. All right, what questions do you have?